Do you see it? I'm not sure if you can see it. I'm trying to move the screen. It's taking up so much space. I can see the problem. So what's the question again? It's, hold on. Oops, sorry. Again, it's, maybe it's better if it's white. Oh, no. What did I do? Oh, no, not that. Sorry. Why is it not appearing? Remember, they can change the background. That one, sorry. Maybe it's better if it's this one. Yeah, it's better. Can you see it? Sorry, I'm using my tablet, so can you use your audio and tell me if you can see it? Can't read your chat. Can you see what I'm doing right now? Hello.
We can see it, sir.
Okay, great. Okay, so gradient descent. How does it work again? Here's the equation. So basically, you have this data, and the new value of the data would be the previous one minus learning rate times the derivative. So there's f of x. Yeah, and this is basically x. It's gonna be x now in this case. X now in this case. This is the equation. Still following? Okay, let's start at iteration 1. Where is it? Hold on. What do we do? Yeah, let's just follow this, okay? So x should be the current value. Sorry, let's x sub 1. And then the learning rate, let's just use variables right now. What's the derivative of the function here? Very easy, but I want to hear it from you guys. What's the derivative? Hello. It's 2x, right? Okay, let's do this now. So what's going to be the new value based on this? 5, 0.1, 10. What's this? So the updated value of x will be 4. And then you keep on doing this. Iteration 2. Let's do the same thing. Right. And then it's basically 2x now. Yeah, just 2x. Then the x, well, it's x1. So what's going to be the value? This one is 4, 0.1, what? 8. What's the value? 2.2. And then after many iterations, what's going to be the value, you think? Say after, I don't know, like iteration. What am I typing? Iteration. Like, I don't know, 100. What do you think is the value? Well, you can keep on doing this, but it will be 0. If you look at the graph here, yeah, the minimum is 0. So the output here is similar to what we're going to get with the analytical approach. Not really 0.8, I believe. Okay, if we continue this, so yeah, let's continue this. What? What's that? 2. It's 2. Well, what's going to be the value? It's 3.2. 0.1, 6.4. What's that? 3.2, 6.64, 3.2, 0.64. It's going to be the value of this. It's 2. Believe it's 5.6, right? Not so. It's not every time. It's not 0.8 every time. Changes. It changes. So if you try to like graph this thing, this is the loss function. Think of this as the loss function. You start here. I don't know. 5, 4, 3, 2, 1, right? This is 5. This is too small. 5, 4, 3, 2, 1, 0. You start. Start. Sorry, it's not perfect parabola, but you get what I'm trying to do here. Start here at 5, then will be like 4, then 3.2, then 2.56, then it will descend slowly. Still following? So after many iterations, you'll end up here. 0. Got that? Got that? So if you do it for the value of x for the 4th iteration, then you just do the same steps. You see that it will descend slowly up until you get to 0. Okay, following? Thumbs up, or let me know if you have questions. Any questions? Are you good with that? Oh, sorry, I think my screen. Okay. Stay there. You sure, guys? You can follow? Or you need more examples? How about the math people? I believe that's easy for you guys. Right. Okay, we'll proceed to the next one. This one. Sorry, this one. How we do this? What if this is our function? So now it's 3D. So we're not limited to 2 dimensions here. It could be like this. Sorry, I am not sharing my other screen, so you can't see it. But anyway, this is the other example. The learning rate is 0.5. Then the initial value would be, say, for example, 2, then y is equal to 5. Okay. Great. Unfortunately, it's 3D, so I can't show it to you like this 3D. But anyway, let's compute for it. Okay, let me try. Anyway, I'll be showing the slides for it later, so you will see. But it's like this. Think of I don't know how you draw this thing, but it's 3D. It's like a net. There's something like that. But anyway, it's 3D. So yeah. So iteration 1 again. So what's the algo again? We compute for this. So x is equal to x minus this, the learning rate, then the derivative, partial derivative f of x y over this one. Yeah, with respect to x. For the y, it's going to be like this. Y. But based on the equation, what's going to be this one? What is the derivative, guys? It is what? Based on this example, what's the derivative of f with respect to x? Math people. Sorry, close again. When you drill, you get the x dy, right? So it's gonna be this 2x. It's just 2x in this example. This is a very easy example. And then this one is, it's gonna be like this. Just 2y. Just like that. Right? Yeah, it's like that. Okay. Questions? Okay, let's do this. For the new value of x. And then basically just 2x. So 0. So it's what now? 2 minus 0.5 times what? 2 to 4. What's the value? It's just 0. How about the next value of y? Y sub 0 minus the learning rate times 2, then the initial value of y, which is 5. So 5 minus 0.5. Then what is this? 2 to 5, 10. Sorry, 2 to 5, yeah, 10. 0. What do you think will happen with iteration 2? What is the output? Okay, let's do this together. If you're not sure. Iteration 2. Sorry. We see there. Yeah. Then 2x sub 1, right? And then the value again, it's 0. It's 0 already. Then 0.5, right? Then 2 times 0 is of course 0. So yeah, it's 0. Y sub 2 is y sub 1 minus our learning rate 2 y sub 1, and it's going to be 0 as well. Why is that? Well, straightforward based on the equation. It's going to be 0. So whatever you do, it's always 0 after iteration 1. What are your thoughts about it? So you can see that after iteration 1, we have already converged. We're already at the minimum. Right? So what do you think is the lesson there? Any hunches? Lucky guesses? Educated guess, I hope, based on what you've seen. Can you zoom out? So it's this one. So basically, if you start with good initial values, you can immediately go to the minimum point. You will converge faster. Because I made this function, I know already the best starting value for this. So I made it in such a way that I will already converge after the first iteration. And the good thing with programming is we could simplify those things for us, of course. That is still the whole algorithm. You have to do all of those things. But with computers, you could just do a for loop and keep on doing that up until you converge. So that's actually your homework. You have to implement that. The algorithm is generally simple. Compute for the derivative. You multiply it to the learning rate, you subtract it from the original value, keep on doing that up until it converges. At least at a high level, it seems easy, right? Questions? But again, that's the gradient descent in general. We will have to do that in the context of linear regression. So there will be some nuances. It will be a bit more complicated than that, but the general algo stays the same. It's always that. So it's really good if you know the fundamentals. You can apply this to whatever problem. Okay, try to do this. Non-graded seat work, but of course, bonus points for CP. Try to answer those. Then give your thoughts about given problem. What do you think is happening? I'll give you 5 minutes for this. I think it's negative 0.5 instead of 1. Just did some mental math. I think it's negative 0.5, not 1. From negative 1, it will be like this. Anyway, I guess you can answer me probably next session. Let me know about your observations on the following questions. Just give me your thoughts. All of my questions are actually intentional. There's a lesson for each of the question that I'm giving for this particular topic. I carefully chose the values. Anyway, yeah, we have to proceed to the next part. Okay. Yeah. Oh, the answer is there. I didn't forget that. Oh no, it's another question. Thought the answer is there. I forgot. But yeah, another question. But let me answer that next time, I guess. Anyway, okay, let's proceed.